Check. Hello. Hi, Tejasri. Good evening. Good to see you. Check. Just trying to see whether the audio is fine or not. Yeah, sounds good to me. I don't see a problem as such. Okay, people. So, as announced on the portal, there is a change in the timing of the bridge course. We brought about this change because we are now in the middle of June, and a good number of coaching institutes will now start having their coaching classes. So that is the reason why we have decided to shift the live session to 7:30 p.m. today. I would like to tell you, please don't fix 7:30 p.m. as of now. Today is a trial. We will continue changing the timings. If we are finding that there are less number of students at this time, and there were more number of students at 12 p.m., we will go back to the 12. We might go back to the 12 p.m. model. We might go back to 12 p.m. And if this suits us, if we see an increase in the number of live students, then we will continue to have this at this time. Regardless, we are almost done with the physics portion. We have some portion of differentiation left and some problems on integration left to do. Once we finish that, we will be done with calculus. So we are done with 90%. We will, in a couple of days, we will be done with 90% of the physics bridge course. And then we will just have one chapter which is intro to 1D kinematics. We will discuss that at a very basic level. And we will close the bridge course. Actually, bridge course is supposed to end when calculus ends. Anything beyond calculus, any chapter related to kinematics or anything is actually a part of 11th syllabus. But I would still like to discuss one intro session, just one intro to 1D kinematics. And by the time we finish one intro to 1D kinematics, it might be June 19th or June 21st. Then whatever 8-9 days we have in hand towards the end of June, we will utilize those days for what? For discussing some maths topics. Okay. So that's why even if we are fluctuating the timings, I would like to say just keep an eye on the announcements. Keep an eye on the announcements on this channel. Like today, you would have seen a notification saying that the bridge course timings have been shifted to 7:30 p.m. because we wanted to shift it and see if there is an increase in the number of live students. But as of now, I can only see 2 people who are live, and there were many more when we were having it in the afternoon. So we might shift back to the afternoon. So please keep an eye on the announcements, right? If you are interested in the bridge course, number 1. Number 2, press the bell icon for this channel. If you haven't pressed the bell icon, you will not get a notification when a live class is about to begin. So only if you press this bell icon, only if you press it, not just subscribe to the channel, you will get a notification of when a live session is started. So even if you miss out on the announcement, you will still get the notification that the class has begun. Okay, so please do these things. Press the bell icon, keep an eye on the announcements bar. We might play around the time. We might play around with the timings for a short while. If nothing works, then we will go back to our afternoon model. Anyways, we only have 10% of the physics bridge course left, and maths we don't have a hard syllabus to finish in maths. I will just come up with whatever random topics I feel like I feel you should know before beginning or you're beginning your 11th, and you can just follow me with that. Okay, people, that's all. Let's move on. I had told you in the previous class that I will give you the concept of or the law for three differentials, three functions, three composite functions. Chain rule for three composite functions, right? We had discussed it for two in the previous class. You can see that from the video. I have given detailed explanation about this. F of g of x, if you want to differentiate this fellow, it has to be first differentiate f of x and keep the input as it is and multiply this with differential of g of x. Remember guys, this term and this term are not the same. These are not same. Okay, why? Because here you are differentiating the whole thing, and in this fellow you are only differentiating f, and you are keeping the input as g of x, keeping the input as g of x, but you are not even touching g of x. You are not touching g of x in this block. You are only differentiating f. But whereas this notation is concerned, you are differentiating the whole composite function. That's why these are not the same. Please keep that in mind. Okay. We have also discussed an example. I first explained you what composite functions are in the previous class. You can refer to that, revise that if you wish. And we also discussed something else. We discussed a question also to demonstrate this formula to you. But then I had asked you, if you have three functions, let's say you have sine of log of x square. I didn't give you this example. I think I gave you sine of log of mod x, something like this. Then if you have this, then how will you differentiate, right? So forget that. Look at this now. Look at this. So how many functions do you think are there in this? Does it only have two functions? You might say that one function is sine, the other function is log x square. But then this log x square also is made up of two functions. It is made up of log and x square. Correct? So actually there are three functions here. Oh, was it that Tejasri? Okay, fine. Forget about that. Just look at this now. If you put mod of log x square, then that will become four functions. So the first idea is you should be in a position to look at this and tell me two things. Number one, how many functions are there in this one composite functions? How many functions are incorporated? That is the first question that you should be able to answer. Second question is, what are they? In fact, there is one more question that you need to answer. What is the order of composition? What do I mean by order of composition? It means if you can break these functions down into three blocks, then which block will come first? Will sine come first, or will log come first, or will x square come first, right? And which will come second and which will come third? Like which will be the leftmost block, which will be the middle block, which will be the rightmost block? That is called as the order of the composition. So you should be in a position to answer all that. Only then you can start applying the chain rule. Okay. And by the way, guys, in the initial days, since you are learning these things for the first time, it might get a little difficult for you. Like this process of breaking this big function into 3-4 composite functions and then giving them an order and then applying the chain rule on that, you might feel that this whole process is very tedious. But as you differentiate more and more functions, when you develop that mental pattern to solve these things. When you develop that mental pattern, then you will not have to, you will do these 3 steps in maybe 1 second. Like I'm in a position to do this in like 2-3 seconds, right? Not 1 second. 1 second is too too small. Maybe you will do it in 5 seconds, right? I will look at this and I'll I'll just place the functions in the order and it'll be done. Even differentiation for me is hardly going to take 5-10 seconds. So you also will reach that position, provided you first understand the concept, you start applying that concept to problems, and then as you practice more and more problems, your mind will develop the patterns to do these steps at a high speed, right? You will not feel that you are slow. So right now, do not try to hurry up and don't. Your idea should be to answer it right instead of answering it fast. Okay, keep that in mind. So number one, how many functions are there in this? 3. Tejasri is right. 3 functions are there. Second question, what are those functions? With practice, you will know there are 3 functions here. One function is sin x, the other function is log x, and the third function is x square. This function that you see is a combination of these 3. Now third is the order of composition. What is the order of composition? When you have sine of log of x square, first you have x square, right? The innermost is x square, so on the leftmost you will have x square. Then as you move out, you have log x, you have log, so log will come next. Then as you move out, you will have sine. By the way, these x's that you see, these x's signify input. Okay, these x's, so I can just remove this x and I can say only log. I can remove x, I can say only sine, right? And this is x square, which means input square. Whatever you give to this fellow will give the output as square of that. So if I give x as input, x square will come out as input. And to this fellow, if I give anything as input, it will give log of that as the output. So I'm giving x square as input, so log of x square will be at the output. And this fellow, no matter what you give to this, it will give sine of your input as the output. Here your input is log x square, so it will give sine of your input, which is sine of log x square, as the output. That's your function. Now the question is, how do you apply chain rule to this? Because this is, let's say this is f of x, and let's say this is g of x, and let's say this is h of x. Then this function is something like d by dx of f of g of h of x, correct? 3 functions, 1, 2, and 3 functions. So how will you do this? Number 1, you will first differentiate the outermost function. Okay, by the way, this is not f of g of h of x, according to the, because my f of x is x square, no, and x square is innermost. So this is h of g of h of x, h of g of f of x. Actually it is that, right? Since my f is this, g is this, h is this, this function that you see here is h of g of f of x, not f of g of h of x. Okay, Tejasri is saying cos of log x square into half x square into 2x. Oh, into 1 by x square. Okay, let's see, Tejasri, maybe you are right. Okay, so the first idea, people, first what do you have to do? First differentiate h. First differentiate h and keep its input as it is. What is its input? G of f of x. Keep the input as it is. Then go to your second function, g. Differentiate that function g and keep its input as it is. What is the input of g? F. So keep its input as it is. Are you understanding the pattern? I hope you are. Then move to the final innermost function and just differentiate that function. So first you go to the outermost function, differentiate that and keep its input, what was the input of h? This red part was the input of h, right? This red part. So this red part you will have to put as it is after differentiating. Then go to the next outermost function, or like go one level inside. So from h you will go to g. You will only differentiate g. And what is the input of g? What is the input of g? This blue is the input of g, f of x. So you will keep the input of g as the same after differentiating it. And then to this you will multiply the differential of the innermost function. So let's see. Let's apply this rule. And let's see if Tejasri's answer is correct. So when you differentiate d by dx of sine of log of x square. What is your outermost function? Sine. So you have to differentiate sine. When you differentiate sine, what do you get? You get cos. Correct? Go to the table. You have to refer to the table. For the fundamental formula, you have to refer to the table because you have to memorize it. So cos is what you get when you differentiate sine. And what is the input of sine? Log x square. Correct? So the input of cos also will be log x square. Okay. So I am done with the first term. This first term is done. What is this first term? Cos of log x square. Let's go to the second term. For this, I will have to go one level inside. From sine, I will now have to go to log because log is my next outermost function. What is the differential of log? Like when you do d by dx of log, like when you differentiate log function, you would know this formula, right? D by dx of log x is 1 by x, right? So 1 by, what will I put here? What will I put in the, if I had log x, I would put 1 by x. Since I have log of x square here, I'll put 1 by x square because input will be the same. When you differentiate log, it will become 1 by something, and that something is the input. That input has to be the same. If that input was x square, here also it will be 1 by x square. Now I will have to go to the innermost function because I am done with this second term. The second term is done, and this second term has given me 1 by x square. Now I'll have to come to the third term, which is differentiating the innermost function. What is the innermost function? X square. Correct? So when you differentiate x square, what do you get? 2x. Correct? D by dx of x power n, I have given you the formula, n into x power n minus 1. Put n equal to 2, you will get this result. Okay? I hope you are following whatever I am saying. I am trying to keep it as slow as possible. Into 2x. Correct? So the answer to the question is cos of log x square into 1 by x square into 2x. You might cancel this x if you want. It will be cos of log x square into 2 divided by x. Correct? By the way, this is x square. This is not log x whole square. Okay? It is log of x square. So people, you might get differentials like this in physics where 3-4 functions are combined. You might, or you might not also. Usually you will not. But in maths differentiation, you will get these kind of questions where there will be many functions, like there will be 4 or 5 functions which are a composite of each other, like which make up the composite function, and then you will have to apply chain rule to that to differentiate. So whatever we have learnt about chain rule. So yeah, Tejashree, your answer was right. Congratulations. You're doing pretty good actually. You are following everything in the class and you're answering as well. Quite, I appreciate it. So moving on, let's extend the understanding of chain rule to many functions now. Like first we discussed chain rule on 2 functions. Then we discussed chain rule on 3. Now we will discuss chain rule on many functions. Like let's say you have n functions. D by dx of f1 of f2 of f3 so on. Let's say your innermost function is fn of x. Right? So you have those many brackets. If your function is like this, like composite of a composite of a composite, like that. Okay? Then how do you solve such a case? So if you want, you can construct the blocks. First fn will come to the rightmost side, leftmost side, then fn minus 1 will come, then fn minus 2 will come. Like that, if you keep going, f3 will come, f2 will come, and finally f1 will come. So your x will go as the input to fn and it will come out from here. This entire combination that you see is this composite function. Okay? So how will you differentiate this? So whatever we have learnt about chain rule, we will extend the same understanding, right? And how do you do this? First, take the outermost function, which means take the rightmost function and differentiate that rightmost function and keep its input as it is. What was the input of the f1 function? It was this. So differentiate it and keep the input as it is, which means f2 of f3, so on, fnx. Keep the input as it is. To this multiply the differential of the second rightmost function, which means the second function, second outermost function. Second rightmost function in this arrangement is the second outermost function, or maybe one level inside. You can imagine it however you want, right? If f1 is the outermost function, it will come to the rightmost. If f2 is the second most outer function, it will come to the second most right. And fn, which is the innermost function, will come to the leftmost side. Correct? This arrangement is clear. So now pick this fellow, pick this f2, pick this fellow, pick the second most right function, differentiate that fellow, and check what its input is. How will you differentiate it? To differentiate it, you will have to look in your table. It will definitely be one of those 10 formulae that you have in your table. Okay? Because the idea is, when you are breaking down composite functions, like what did we do here? When we had sine of log of x square, we broke this down into three functions, right? Sine x, log x, x square. All these three functions had the formulas in the formula sheet that I gave you. In the 10 formulas that I gave you in the formula sheet, all these three functions are present. So when we break down a composite function, we have to break it down in such a way that all the functions that we get after breaking down, their formulas should be present in that sheet. So it will happen, don't worry about it. You will find those formulas in that sheet because you have broken the function down in that way. That is how you break it. So if I did not tell you already how I have been breaking these functions, if I did not explain you how is it that from sine log of x square, how did I say it's x square, log and sine? It's because I know the formula for x square in that sheet. I know the formula for log in that sheet. I know the formula for sine in that sheet. So I have to break down my given function in such a way that I find those find the differential formulas for each of these blocks in that sheet. Okay, I hope now you have a pattern to think. So you will differentiate f2, and what is the input of f2? This red part is the input of f2. From f3 to fn, everything from f3 to fn is the input of f2. So start with f3 and go all the way up to fn. Like that, now you will pick the third most inner function, differentiate that, and check the input of that. Everything from f4, let's say there was an f4, everything from f4 to fn, that is the right input. Like that, you will keep following this process and you will finally end at fn dash x. So guys, this is the chain rule. This is the chain rule for n functions for you. You don't have to memorize this. You don't have to memorize this dirty looking long formula. You have to understand the pattern, right? You have to understand the concept. The concept is when you have a composite function which is a combination of many functions, you have to break those functions down into those functions, those fundamental functions whose formulas are present in that sheet. Then you will have to arrange them like this, and then you will have to apply chain rule from the rightmost side. Pick the rightmost side function, differentiate it, keep its input as it is. Then pick the second most right function, differentiate it, keep its input as it is, and follow that until you reach the end of the chain. This is called as the chain rule. Okay. Let us now solve some problems on differentiation. Okay. After we finish these problems, tomorrow we will pick up some problems on integration. Let me just have water and come, people. Alright, so I am back. By the way, tomorrow we will not straight away start with integration. We have one more topic to cover in differentiation, and that is maxima and minima. And this maxima and minima, guys, it's very, very, very crucial. Probably this is why we are studying calculus. A lot of application of differentiation in physics is to find maxima and minima. We will see tomorrow what this maxima and minima means. But before we even see this, you need to first learn how to use those 10 formulae and these 4 laws that we have seen. What were the 4 laws? Sum, difference, sum and difference were together. Sum slash difference in integration, product rule in integration, not integration, differentiation. Sum slash difference in differentiation, difference rule in differentiation, product rule in differentiation, division rule in differentiation, and chain rule in differentiation. You can combine these 10 formulae and these 4 laws to differentiate any damn function that's given to you. You can use this to differentiate any function that's given to you. By the way, I want you to add one formula to those 10 formulae and make it 11. Because maybe that I didn't give you that formula, but it's important. You might get it, I don't know. Somewhere you might add this formula, add the 11th formula to the list of differentiation formulae. And that is d by dx of mod x is mod x by x. Like if you have your function as mod x, and if you differentiate, like what will mod x do? You give any x as input, it will give the absolute value of that. If you give x as -1, 1 will come out as output. If you give x as 1, then 1 will come out, right? So this function is known as mod x, and there is a formula for this also, but there is one condition here. Mod x is not differentiable at x equal to 0. So this formula is valid only if your x is not equal to 0. Clearly, because you have an x in the denominator. No, if your x becomes 0, then how will this be valid? So this formula is valid only if your x is not 0, right? And if it's not 0, then the formula for differentiation of mod x is mod x by x. Okay, add this to the 11th as the 11th formula. Maybe you will not need this a lot in physics. This function is not very popular in physics, but you might get, I don't know. So I just want you to be safe. That's why I give it to you. Okay, let's discuss some problems now. We will just use these 10 formulae and these 4 laws to solve all these problems that we discussed today. Let's see how many people can answer. Question number A. Very straightforward actually. Differentiate the following functions with respect to x. What do you mean by with respect to x? If you have any function, if I say df by dx, like d by dx of, then this means I'm differentiating the function with respect to x. Okay. First question to you guys. Sin y. If you have a function sin y, and if I ask you what is d by dx of sin y, what will your answer be? Tell me. D by dx of sin y. I have given this to you in the list of 10 formulae. Let's see. There is a catch here, which is why I have given this question. Can somebody do this? Actually, I don't even have a lot of people live, so there is no point waiting. Let me just tell it. It's 0. Why is it 0? Yeah. Actually, Tejasri has given the more apt answer. It's actually cos y dy by dx, but I will not touch this because it's a bridge course. Instead of that, I will say y and x are independent. I'll give this in the bracket. If y and x are independent, then dy by dx will become 0. Correct? So that's why the answer to this will be 0. Because sine y will behave like a constant when differentiated with respect to x, which means if you give x as input and if you change this x to something else, let's say you change it to x plus dx, the output that you get from x, let's say, is y. The x plus dx, if you even if you change it to x plus dx, you will still get y. Like there will be no change in the output. So change in input will not result into any change in output, and we have seen when that happens, then differentiation, then it will be 0. Like remember that formula, dy dx of constant is 0. I've given that formula in the list. Why? Because constant function is that function where even if no matter what input you give, output will not change, output will still be the same. And when that happens, differentiating that function with respect to the input is 0. Here sine y, even though it's not really constant, because if you give y as input, then output will keep changing. Like if you give y equal to 1, output will be sine 1. If you give y equal to 2, output will be sine 2. So if you change the input y, output will change. But if you give x as input, and I have told you that y and x are not dependent, then changing x will not result into any change in output. That's why with respect to x, this sine y will behave like a constant. So this formula will come into use for this fellow. Okay, very important guys, very important. Please understand this. And if you don't, that's why we have these classes live, so that you can ask me your doubts live, number one. And number two, if you're watching this recorded, please put your doubt in the comments box, but please be clear with all this. Okay, moving on. Next, differentiate this. By the way, whatever questions I give you, you have to differentiate it with respect to x. I have already given that here. Okay, differentiate the following functions with respect to x. So whatever I give you, you have to differentiate that with respect to x. X cube plus 5x square minus 2. Even before you start differentiating it, you have to first identify what all will you use here. Number one, what formulas will you use and what laws will you use? As far as formulas is concerned, yeah, you are right, Tejasri. As far as formula is concerned, I will use this dy dx of x power n, because you can see there is an x power n here, there is an x power n here, there is an x power n x power 0 here, right? And as far as laws are concerned, we will use the sum slash difference laws, because functions are not being multiplied, they are not being divided, they are not a composite, they are only, so you have one function f1, f2, f3, and these f1, f2, f3 are only being added and subtracted. So that's why I will only use sum and difference laws. Correct? So what does this law say? D by dx of f1x plus f2x minus f3x, what is it? It is d by dx of f1x plus d by dx of f2x minus d by dx of f3x. I have discussed this law already with you. Okay. So how do you differentiate the first function? You will use this formula. How do you differentiate x cube, which is your first function f1? 3x square. Use this formula, d by dx of x power n equal to n into x power n minus 1. Use this from the list. So you will get 3x square as the first term. Second term, 5x square. 5x square, how do you differentiate this fellow? D by dx of 5x square. You can pull 5 out. You can say 5 times d by dx of x square. So guys, there is one more thing that we see this from this formula. If you have a function d by dx of k into f of x, if you want to differentiate this, and if this k is a constant, with respect to x, which means if changing x does not have any impact on the output that you get from the constant. That's how a constant is, right? If you give x equal to 1, output will be k. If you give x equal to 2, doesn't matter, output will still be k. Keep changing your x, k will not change. Okay, output will not change. So anything, if this k can be sine y also, if y and x are independent, right? The point is, if this entity is a constant with respect to x, which means changing x does not change the output from this entity, then you can pull this out. You can pull this out of the integral differential. You can pull even, you will see that even in integral I can pull it out, but in differential also I can say k into dy dx of f of x. Okay, so that's why, because of this reason, I can pull the 5 out. I can say 5 into dy dx of x square. Now how do you differentiate x square? Again, use the same formula, dy dx of x power n equal to n into x power n minus 1. Put n equal to 2 and you will get 2x. So your answer will be 5 into 2x, okay, which is 10x. Finally, you have this minus 2 actually. So your third function is a constant. Your f3 is a constant. When you differentiate a constant with respect to x, what will you get? What is d by dx of constant from the formula sheet? It is 0, right? That's why this f3, which is a constant function 2, will give you a minus 0. That's why the answer is 3x square plus 10x, right? Please guys, I'm taking it slow because there are people who are actually doing differentiation for the first time, and if I speed up, people will go mad. So keep following, keep solving more. Let's see what's the next problem we have. We have f of x equal to x into sine x. Please differentiate this. Tell me the formulas and laws that you will use first, then use these formulas and laws to differentiate it. So the formulas that you will use is d by dx of x is the first formula that you will use, then d by dx of cos x. No, Tejashree, your answer is not right. Please check. These are the formulas that you will use because you have identified your functions. Your function is f1 and that is this, and f2 is this, and f1 and f2 are being multiplied here, correct? So you will also have to use product rule. You will also have to use product rule. So d by dx of f of x, which is nothing but d by dx of f1x into f2x in this case, where your f1x is x and your f2x is sine x. I don't think your answer is still right, Tejashree. Let's see. So what is this law? What is the product rule? First, differentiate f1 and multiply that with f2 as it is. Then differentiate f2 and multiply that with f1 as it is. Okay, you will have to do this. If you are not clear with this, please see product rule again from the previous class. D by dx of f1x. What will this give me? What is d by dx? What is f1x? X. So what is d by dx of x? Isn't this 1? Because what formula will you use? D by dx of x power n is equal to n into x power n minus 1. You will use this from the formula sheet where you will put n equal to 1. If you put n equal to 1, you will get 1 into x power 1 minus 1, which is 1 into x power 0, which is 1. That's why d by dx of x is 1. Okay. So this is 1 into what is f2x? Sine x. Put it as it is. Next, d by dx of f2x. What is f2x, people? It is sine x. So what is d by dx of sine x? It is cos x. We all know that. So put cos x here and multiply f1x as it is. What is f1x? X. Multiply that as it is. So the answer to this question is sine x plus x cos x. When you differentiate this fellow, you get this. Alright. So please, although it might seem that I'm going a little slow, I'm trying my best to not go too slow, but if you're not careful when you're learning differentiation in the beginning, you will get used to calculating with mistakes. Like you will develop this habit of doing a problem faster, but then you will end up committing a lot of mistakes. So please go slow but go right. Develop this habit and then increase your speed so that you get the right answer in the first attempt itself. In the exam, you will not have the time to solve a question, then check whether it's right or wrong. Because the moment you will only get 2 minutes or 2.5 minutes per question. So you have to solve that question correct in the first attempt itself. You can't really afford to develop this habit of committing mistakes while doing calculations. Okay, people? Question number C. If your f of x is 2x plus 3 whole power 6, what formulas, what laws? First of all, even before we decide these, as you can see, what I've been repeatedly doing is I've been first finding what my functions are. Correct? So this fellow is a function, f1x. f1x equal to 2x is a function. f2x equal to 3 is a function. These two functions are being added and they are being raised to the power 6, which means there is a third function also which is not visible to you, but it is present, and that third function is x power 6. And you guys know this is, I don't know if you guys have realized, this is a composite function. It's a composite function which is made up of these three. Actually, these two are added, and then this combination and this are like a composite, which means first f1 is added, then f2 is added, and then this is fed to f3. So f1 is a function, f2 is a function. You are adding these two functions and you are feeding this function to f3, which is x power 6. That's why finally what you are getting is f3 of f2x plus f1x. This is how your, so this is not just a composite functions. This is like adding two functions and then constructing a composite function. So now that the construction of the function is clear, I hope it is, since nobody is asking anything in the chat box. What will we do? Now we can identify the laws. Since there is addition that's involved, I will have to use the sum/difference rule in differentiation. Sorry, first formulas. So since there are only polynomial functions 2x, 3, and there is something power 6. So this d by dx of x power n equal to n into x power n 1 minus 1. This one formula is sufficient. I don't need anything more, because all functions and even the composite function is a polynomial function, and this is the polynomial formula. Correct? This is the polynomial formula. Out of those 10 formulae that I gave you, this one is known as the polynomial formula. And what all laws do we need? We need the sum/difference laws. In fact, difference is not needed because they are only added. But we also need chain rule, guys. We need chain rule because f1 is added to f2, but then these two are fed to f3, which is x power 6. So it's something like f3 of f1 x plus f2x. So there is composite functions involved here. So I will obviously have to use chain rule also. Now let's see how we can use these laws. So first let's see how this function looks like. This function looks like f3 of f1x plus f2x. So this is like f1x is here, f2x is here. When you give x will go into both and these two will add to come out, and their sum is fed to f3. So now when I start applying chain rule, I will have to apply chain rule from the rightmost side. Correct? I will have to apply chain rule from the rightmost side, which means I will have to just differentiate f3. And what is f1, f2, f3 here? First of all, what is f1, f2? f1 is 2x, f2 is 3, f3 is x power 6. So when you differentiate the outermost function, x power 6, what is d by dx of x power 6, guys? 6 into x power 5. Use this formula, d by dx of x power n, and put n equal to 6 in that, you will get this. But what is the input that you are getting to f3? The input that you are giving is 2x plus 3, right? So instead of saying 6x power 5, I will not say 6x power 5, I will say 6 into whatever the input is, 2x plus 3. 2x plus 3 is the input, no, for f3. So 6 into 2x plus 3 whole power 5. This is the first term. Then I will come to these fellows. So these two together are like a function. They together are like a function. And these two can be differentiated using the sum rule. So you will have to first differentiate f1x and then you have to differentiate f2x and add them. Simply apply sum rule. So when you differentiate 2x, you will get 2. When you differentiate 3, which is f2, you will get a 0 because it's a constant, right? Differentiation of a constant will give 0. So 2 plus 0. So what is the answer? 12 into 2x plus 3 whole power 5. Yes, Tejasri, now you are right. 12 into 2x plus 3 whole power 5. But can you see, it's not easy, guys. It's a little tricky. That's why I'm using these blocks method to explain you. First, construct the composite function properly. Sometimes you might have more than one function at the same level, which means if f1, like as you can see, this is not f1 of f2x, right? This and this, they are not the same. Here f1, f3 and if I construct the block diagram for this, it will be f2 first, then f1, then f3. But if I construct the block diagram for this, it will be f1 and f2 in the same level. In fact, these two are together a function, let's say f4, and f4's job is to add f1 and f2, right? And then this, like the sum from these two is together fed to f3. So can you see the block diagrams are different? That's why first learn the construction of the function, then start applying chain rule from the rightmost side, and then you might have the need to apply other rules, other 3 laws also when you are traversing from the right to the left, like we had in this problem. As you solve more and more problems, things will be clear. Okay, let's look at the next question, which is E part. D by dx of, I want you to find me this x by sine x. Now this is relatively simple than the previous one, because I just have to identify the elementary functions. What are my elementary functions? F1 equal to x. What are elementary functions? Those functions whose formulas are available on those 10 sheets that I had, or like in those 10 formulae that I had. What is f2 sine x? These are my elementary functions. And if you look at this fellow, it's simply f1x by f2x. So now I know there are only 2 formulas I need. There are only 2 formulas I need to solve this. What are the formulas that I need? D by dx of x is one formula. D by dx of sine x is one formula. Both of them are available in the sheet. What are the laws that we need? Only one law, and that is division rule. Division law or division rule in differentiation. Correct? So let's combine these. So we first start seeing from the laws perspective, always, as you must have seen in the previous problems also. When you have d by dx of f1x by f2x, you first do d by dx of f1x, multiply this with f2x, subtract d by dx of f2x, now differentiate the second function, denominator function, and multiply this with first numerator function as it is, and then divide this with the square of the denominator function. This is the product rule that I've already discussed with you, correct? Now when you differentiate the numerator function, when you differentiate this x, what do you get? 1, right? So you'll have a 1 into, okay, Tejashree, let's see if your answer is right or not. And then f2x is multiplied as it is. What is f2x, guys? What is f1x here? X. What is f2x? Sin x. So 1 into sin x minus, what will you have here? D by dx of f2x, which means differentiating cos x now. Sin x. Differentiating sin x. When you differentiate sin x, you get cos x. Fine. Next, multiply with f1x as it is. What is f1x? X. Multiply with it as it is. Sorry, I have to hide myself. Then what is the final denominator here? Square of the denominator from here. What is the denominator here? f2x, sin x. So sin x whole square, right? So Tejashree has written sin square x. That is also sin x whole square only. But yeah, if you write sin x square, this is wrong. This and this are not the same. Okay. So the answer to the question is sin x minus x cos x by sin x whole square. Okay, that is the answer to this question. Fine, as you guys can see, it's a little involving, people. These questions can get involving unless you have complete conceptual clarity and the patience to apply that concept without any mistakes when you are learning it for the first time, the way you are doing now. Don't be in a hurry to give answers and give wrong answers. That's a wrong habit of solving problems. Finally, we are here. This is the final question for the day. E power 5x plus 2. This function is also given in that list. If you haven't memorized that list, it's a different thing. Okay, it's a little tricky. What all is there here? What all laws, what all formulae? Before that, what are the elementary functions? Let's see. f1x equal to 5x is my first function. f2x equal to 2, which is a constant function, is my second function. And there is one more function. f3x equal to e power x. Now, if I draw the block diagram for this construction, it's something like this. You have f1x, you have f2x. These two are being added. And the output that you get from the addition of these two, that is fed to e power x. That is fed to e power x. So in a way, this is nothing but f3 of f1x plus f2x. Right? Very similar to one of the problems that we recently did, like 3 problems ago. So how will you start this? Finally, first of all, what all formulas do you need? You need the formula to differentiate 5x, which is a polynomial function. You need a formula to differentiate 2, which is a constant function. So d by dx of x power n is one thing you need. D by dx of constant is one you need. This is a polynomial. And d by dx of e power x. Like, you need to know how to differentiate this first of all. Next, what all laws do we need? We need chain rule, because there is composition involved and there is addition involved. So we need some rule also. Some rule. Okay. Now let's start. Let's start with application. So when we apply, first we have to apply chain rule. Okay. When we apply chain rule, we have to start from the rightmost side. Start from the rightmost side. When you start from the rightmost side, you have e power x. So when you differentiate e power x, you get e power x only. But will you put e power x? Will you put this x? No, you will not put x. You will, instead of x, you will put the input that's going to this e power x. What is the input that's going? This function plus this function, which means 5x plus 2 is going as input. So you will put 5x plus 2. Instead of e power x, you will put 5. Instead of e power x, you will put e power 5x plus 2. Because 5x plus 2 is the input that's going into e power x. Now you will multiply this with the differential of these. Since these two are at the same level, Like since these two are not like f1 and then next you have f2, these are not like that. These are not like this. They are at the same level. So there is no need of chain rule anymore. The chain is completed. You have reached the end of the chain. The chain only had two levels. This is the second level from the right side. This is the first level. Once you finish that first level, come to this, you have ended. So chain rule, forget about chain rule now. Only come to sum rule. Okay. And sum rule is when you differentiate these two, sum, then it will be d by dx of f1x plus d by dx of f2x. f1x is this, so when you differentiate this 5x, you will get a 5. When you differentiate f2x, 2 is a constant, so you will get a 0 when you differentiate it, because differential of a constant is 0. That's all. Your answer is 5 into e power 5x plus 2. Please guys, please get used to this block model. You will never go wrong. Once you solve enough problems, then you will not need this block model anymore, because your brain will have developed enough patterns to solve problems quickly. But for extreme beginners who are struggling with differentiation, this block model is mandatory. Go step by step, solve problems rightly first, develop the confidence, and then think of improving your speed. So we have discussed a few models on differentiation problems today. With this, we are done with today's class. Tomorrow we will see the concept of maxima and minima, as I told you. Don't worry about maxima and minima now. Tomorrow we will see that. It's a very important class tomorrow. Very important class. Please come live. As I said, keep a check on the notifications, announcements, right? Keep a check on notifications and announcements. We might change the timing to afternoon again. Is tomorrow's session on problems on integration or concept of integration? No, tomorrow's session is first half is maxima minima, and then we will start with problems itself. Like integration, we don't have a lot of, integration has a lot of laws actually. Integration does not have 4 laws. Integration has like 12-13 laws, 12-13 types, and that you can't learn now. You're not in a position to learn those laws and concepts now. You will have to learn that in your 12th only. Once you have to finish, you have to do maths for like 1 year to learn those things. So we will not touch those. We will straight away start with basic problems on integration, right? So first half of the class will be maxima minima. Second half will be straight away starting with integration problems. So again, revise those 10 formulae that I gave you for integration, right? And please press the bell icon and keep an eye on the notifications and announcements, right? Take care. See you guys. Bye bye. Stay safe.